write delta V, that is equal to minus W. So that is minus force into displacement. Now take the summation of these two equations. Then we can write delta K plus delta V equal to 0. So delta into K plus V equal to 0. K plus V, that is summation of kinetic energy and potential energy, and that is called mechanical energy, or sometimes it is called total energy. Okay. Now delta means change. So change of the summation of kinetic and potential means mechanical. So change means final minus initial. So we can write this left hand side as K final plus V final minus K initial plus V initial, and that is equal to 0. So if we take this particular term on right hand side, then we can write K final plus V final, that is equal to K initial plus V initial. So K final plus V final. So final kinetic energy plus final potential energy, that is final mechanical energy. Similarly, on right hand side, initial kinetic energy plus initial potential energy. So that is initial mechanical energy. Okay. So for conservative force, always remember this thing, the mechanical energy of the system that remains constant. And this is called the conservation of energy or conservation of mechanical energy. If you remember, in chapter number 1, the statement was given for the conservation of energy. So this is the conservation of energy. So when any object is in the gravitational force field, then in that particular case, if the object is in motion, then kinetic energy will be converted into potential, or potential will be converted into kinetic, but the total that will remain constant. Clear to all of you? Now suppose we consider any object is at height capital H from the surface of the earth. So its initial velocity, it is 0. It implies that at height h, the mechanical energy equal to kinetic energy at height h plus potential energy at height h. Kinetic is 0. Potential is mgh. So we can write EH equal to mgh. Now it is released, now it is freely falling. Suppose it is at a height small h from the ground. At that time, its velocity, that is Vh. Then again at that position, mechanical energy, that is kinetic energy at height small h plus potential energy at height small h. Now at that position, the velocity is Vh. So half m Vh square plus mgh. Okay. Now when it hit the ground, suppose its velocity, that is v, that is vf, and a final કહી શકીએ આપણે. So at the ground, mechanical energy E0, that is kinetic energy at the ground K0 plus potential energy at the ground V0. So half mv square plus 0, કારણ કે ground ને hit કરે એટલે h 0 થઈ જાય, તો potential 0. So E0, that is half m square. Okay? So we can calculate the velocity by comparing the energies at different position, because energy, that is constant one. So at height h we can take the energy, that is mg. અહીંયા સુધારીને capital H કરી નાખજો. Half mv square. So v equal to under root 2g. અહીંયા capital H કરી દેજો તમે લખો ત્યારે. અને in between, suppose કે આપણે આ લઈએ કે કોઈ પણ પોઈન્ટ પાસે એની વેલોસિટી કેટલી. તો at this position, which one is at height small h from the ground? The energy is Eh. At height capital H, the energy is E capital H. So we can write half m Vh square plus mgh, that is mgh. Take m common from both the side, will be cancelled. Then if we make Vh square as a subject, then Vh square equal to 2g into h minus h. Or we can write Vh equal to under root 2g into h minus h. So in this way, we can calculate the speed of the object at any position with the help of this conservation of mechanical energy also. Clear?